So here we go, guys. We're going to take this practice test again. We're going to try to get it done this time with actual sound so you guys can listen to something. So here we go. We're trying to find, is this a right triangle? Well, we know for all right triangles, a squared plus b squared equals c squared. And that is where c stands for the hypotenuse. So really you have to figure out if this was a right triangle, which one would kind of be the hypotenuse? Which one is the biggest side? Well, we know the square root of 24 is smaller than 15. Okay, so we know that it's definitely going to be 15. Well, 15 is bigger than 14 also. So the hypotenuse is the biggest side. Okay, so we're gonna make sure that we notice that's where C is the hypotenuse. So what are we going to test to see if it's true that it's our hypotenuse? We're going to test 15. Okay, so draw your arrow here and let's point at it so we know that's our hypotenuse. Okay, so we're going to put 15 over here, 15 squared. And now we know 14 is A, and square root of 24 is our B. And don't forget to square both of them, right? So 15 squared is 225. 14 squared is 196. And 24 squared is, well, square root of 24 squared is just 24. So if I add these up, do I end up with 225? Well, here I got 225, but adding 4, what do I get over here? Oh, I only end up with 220. So is that true? It's not true. So then we say, no, this is not a right triangle. It's not a right triangle, okay? So that's the way you're going to do these. You test them to see if a squared plus b squared really does equal c squared. If it does not, then you say, no, it's not a right triangle, okay? We're going to move past this example now. And we're going to look at this one real quick. So let's think about it. Let's set everything up, okay? We know that our hypotenuse would probably be this side over here, right? So let's make sure we're going to test our equation and see if that really is a hypotenuse or if this isn't even a right triangle. So we're going to test to see if 13 is our hypotenuse. So we're going to put 13 squared here, and we're going to put 10 squared over here, and square root of 69 squared. Okay? So, well, look, 13 squared is 169. And 10 squared is 100, and it turns out the square root of 69 squared is 69. And if you add up 169, you get 169. So is this equal to 169? Hey, that's true. So in this case, we know, yes, this is a right triangle. Okay, so there you go. This is a right triangle because it's true that a squared plus b squared equals c squared. So now we can move along. Well, every now and then, you're going to have to find the missing side of a triangle. And it might look like we have to use trigonometry on problems like this if you forget the theorem that we just used, Pythagorean theorem. Well, the reason that you use Pythagorean theorem is partly to check if a triangle is really a right triangle. But if you know it's a right triangle, then you know that a squared plus b squared equals c squared. So in the last problem, we were testing to see if this was true. But now, since this is a right triangle, we already know this has to be true. We've proved it before, okay? So we know that our a is 7 and our other b is x. And so our c is going to be the one across from the right angle, and that's 13. Well, 13 squared is 169 as we just saw, and 7 squared is 49. So that's x squared. So if I take away 49 from both sides, we're going to get x squared equals 169 minus 49, and we'll get 120. And so now if I take the square root of both sides, we'll see, x equals the square root of 120. Okay? We can simplify the square root of 120 a little bit over here. I'll put this in blue. Okay? So let's look at how do you break down the square root of 120. Well, I know that 120 is 12 times 10, and 10 is just 2 times 5, right? And 12 is 2 times 2, that's 4 times 3. So I know I got 2 times 2 times 3, right? So this is 4 times 3, that's 12. 12 times 10 makes 120. So anytime you see a pair of a number, it comes outside. So we see only 2, so the only number that can escape is the 2. And everything else has to stay inside and get multiplied. So inside we have 2 times 5 times 3. And 2 times 5 is 10. 10 times 3 is 30. So we get 30 in there, okay? So there you go. You could also say that x equals 2 root 30. All right? 2 root 30. And so there you go. This is how you use the Pythagorean theorem. When you already have 2 sides, you use the Pythagorean theorem to find the third side, okay? But you already have to have 2 sides, and then you can find the third one. So here we go. Move along to number 4. So what I want you guys to remember on problems like this is this little phrase that we talked about to help us remember the definition of all our ratios, of all our trigonometric ratios. So for number 4, it asks us for the tangent of C, okay? So what we should remember is that tangent of C equals the opposite over, well, tangent is opposite over adjacent, okay? So we're going to go over to C and draw our arrow. That's the first step in all of these problems, okay? You have to make sure you go to C. I went to C. Draw your arrow across. Call this opposite. And now what do I call this over here? This is our hypotenuse, and this is the adjacent side. So if I have to do the opposite over adjacent, I know my opposite is 10 because I labeled it, and my adjacent is 24. I also labeled that one. So now we could break this down a little bit. We have 2 times 5 on top, and we have 2 times 12 on bottom. So the 2's can cancel out, and we get 5/12. So we can see that the tangent of C equals 5 over 12, okay? And this is the form I would like for you guys to put when we do the test, okay? Actually reduce the fraction. Do not just leave it like that. This is what we're looking for. I'll take off probably half a point if you guys just leave it that way, okay? So now we're going to try number 5. We just did a tangent, okay? I'll wait for you guys to do it. Go ahead, press pause and try to do this problem by yourself. See if you get it. And now that you're back, let's just go to work, okay? I'm going to show you a way to abbreviate. We could go across here and just call that O, okay? We could go over here and we'll call that H. And we can call this A instead of writing the whole word out, right? Well, we know tangent is the O over the A, the opposite over adjacent, right? From SOHCAHTOA. So our O is 5 and our A is 12. Okay, well now we got the same answer we got last time, but that was just a coincidence, okay? So it's pretty much all you have to do for the trigonometric ratios. These ones aren't too hard. It just makes sure that you know how to use SOHCAHTOA, okay? So you have to know that S stands for sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over the adjacent. Well, if you got that, you're probably ready to move on to special triangles over here, right? So now we're looking at 45, 45, 90s, okay? And we saw when we start off with this picture right here, you want to use this picture to help us out. And it doesn't matter if this is turned the other way. I mean, it's still the same triangle. Even if I take it and rotate it around, it's still the same shape. So don't be disturbed by the fact that it's just rotated around a little bit, okay? So we're going to see that the sides that make the right angle are equal. Okay, so let's look over here. These sides that make the right angle, they have to be equal. So if this is 6, then this is 6, all right? And now this is our hypotenuse. And we could use the Pythagorean theorem to find that if we wanted, but that's the point of special triangles, is to see that we found a pattern that we don't have to do Pythagorean theorem every time. Since these two sides are equal, this is going to be just 6 times the square root of 2. Okay? So you just have to get used to adding this side over here and just multiply times the square root of 2. Okay? It's just like that. So I could even do another one with you guys in case you don't get it yet, okay? Let's put a right angle here and call this 45, all right? If that's a 45-degree angle, this has to be 45 degrees too, okay? So we probably won't write them in every single place. Well, let's say this is a 7. Then that means this one has to be a 7. And the hypotenuse is, right, that's the hypotenuse, is just x, the 7. And what do I have to add? I don't just copy x. I have to also copy root 2. So now I put root 2, okay? This is how you do those special triangles. Well, some special triangles start upside down. And we see on these ones, maybe the first side they give you is actually the hypotenuse, instead of giving you another side, like one of the legs of the triangle. So in this case, the pattern we're going to see is that we have x root 2 over 2, and x root 2 over 2 is the pattern we're going to follow right now. And I don't want this video to run over time, so I'm not going to explain why it's like this. If you don't get it, go ahead and look into it a little bit, use the Pythagorean theorem, and you might figure it out. It's just a little bit of algebra. So here we go, all right? We know that this is 6. Well, x root 2 over 2, we just have to copy what we see. So instead, I'm going to write root 2 over 2, and I'm supposed to copy x right there. But my x in this case is 6. So I'm going to put my 6 right there where it goes. And I'm going to do that for the other side too, because like we said, these two sides are going to be equal, right? So over here I have 6 root 2 over 2, okay? Well, 6 divides by 2, right? It does. 6 is 3 times 2, so I can just simplify this to be 3 root 2, and then this would be the same thing also, right? This also equals 3 root 2. So I hope you see that what we're really doing is just taking half of this number and multiplying it times root 2. So let's try to practice a couple of those on the side real fast to see if you get the hang of them, all right? So let's say you have 8 over here. Well, we know these sides are going to be half of 8 and times root 2, right? 6 and 3. Half of 6 is 3. And then we just multiply it times root 2. So this is going to be over here, if it's a 45, 90, 45, we know this is going to be 4 root 2, because 4 is half of 8. And this is 4 root 2. Okay? Let's try another one. Let's say this is 45 and this is 22, right? Then this is going to be over here. Half of 22 is 11. And then add the root 2. And this is 11, and then add the root 2. So try not to get confused. It's all about which number did they give you first. If they start you off with the hypotenuse, use this pattern that we're using right now, okay? If they give you one of the legs, you have to use the other pattern that was a little easier to use that we did on the first problem. So now, I want to show you one number that doesn't divide so you guys could practice being able to leave it there in that case. So this will be the last one we do, special triangles that are 45, 45, 90. So let's say this is 7 right here. Well, the pattern that we had was this is going to be 7 root 2 over 2. And since 7 cannot divide by 2, just leave it like this. Just leave it as 7 root 2 over 2, and that should be good enough. So we got 7 root 2 over 2, and I want to fix this 7 because that's not looking so good. Okay? So this is the way special triangles work with 45, 90, 45s. Okay? Let us try something new. 30, 60, 90s. Okay? So now we're doing 30, 60, 90s. And I've had a lot of people tell me, oh, what if they give you 60 over here instead of 30 over there? Well, 60 plus 30 is 90, and 90 plus 90 is 180. So this is the way this triangle has to be. If they only show you the 60, you should be able to know that's 30. And if they only show you the 30, you should be able to know that this has to be 60 over there. So like I said, the problems are only going to show you one of the angles, and you're kind of supposed to be able to get the other one. Well, as soon as you recognize this is a 30, 60, 90, you might want to draw this picture on your paper or look at your notes to use this picture, okay? Because the way 30, 60, 90s work is the shortest side is across from the 30, right? And this is the hypotenuse. The hypotenuse is just double our small side. And this side right here, the adjacent side of our 30-degree angle, is x root 3. So this is the way the pattern works. It's not so complicated, honestly. Just look at the hypotenuse, and we have to look at the one that's across from our 30-degree angle So the 1 across from our 30-degree angle is kind of like the key for this whole thing. Once you have that, you can easily do everything else. So let's look across from our 30. What do we have? We got 4. So I know the hypotenuse is going to be double whatever was across from 30. So we have 4 across from 30, so the hypotenuse is going to be double of 4. And 2 times 4 is 8. All right, that's not so hard. Well, for B, this is the only side left, right? So we know this has to be the side that has 4 times root 3. So you like copy the x, it goes over there, but the only thing you add is a root 3. So it's pretty much just face value like how it looks. Just make sure that you do not flip these sides around. You don't want to put them in the wrong place. Make sure you double the side that's actually the hypotenuse, okay? The hypotenuse is the side you want to double. Let's look at another one. So here we go. In some cases, they'll give you the adjacent side first, and you're going to have to figure out what the short side is. Well, the short side is y, right? And we know whatever the short side was, I would add a root 3 to it, multiply a root 3 by it, right? To get the adjacent side. Well, what did I multiply root 3 by? I multiplied root 3 by 4. So this must be 4. And that's just a little bit of intuition you have to use right there. Just cross out the root 3 and then you have this thing over here, okay? And that's the easiest way I could explain it for these kind of problems. Right now, the hypotenuse is across here, so that has to be double our short side, and we get 8. So I could make these problems harder, but it would be harder to see the basic pattern that I want you guys to learn from this. So just focus on these kind of examples that we have. Don't make it too hard for yourself, all right? Here we go. So number 10, we're going to be solving a right triangle right now. So let's start off by doing this. You draw an arrow here, and you come across and call this the opposite. And then we label this as our hypotenuse. Well now, if we use our SOHCAHTOA to see which ratio we can form. Well, we have the hypotenuse and the opposite of this 62-degree angle. So the only ratio we can use is the one that has the O and the H, and that's this one. And this stands for sine is opposite over hypotenuse. So we'll put sine of what? Sine of 62 equals the opposite, that's x, over the hypotenuse, 14. And so now we will come into our calculator and we're going to get sine of 62. Or you're going to look on your table. So we will type in 62 sine of 62, and we get 0.8829. Okay, and then we're going to multiply both sides times, get some of this stuff out the way. We're going to multiply both sides times 14. So what cancels out on the right side? The 14s. We have x equals 14 times 0.8829. And you get 12.36. So it says round to the nearest tenth. So really what we're doing, this is an exact answer, right? If we round, we can use our approximation equal sign. This means that it's approximately equal to 12.4. Okay? So just make sure that you round up. If you go ahead and put the regular equal sign, I won't mark you off or anything like that, but just be sure that you know the difference between an exact answer and the approximation. So there we go. We went and solved the right triangle. I hope you guys have plenty of practice for those ones, because that's definitely you're gonna have 2 problems of that on the test, okay? Definitely an important topic. So let's try this one too, okay? We should do it. So put an arc here, and we'll call this the opposite. And again, we have the hypotenuse. So we know we're going to use sine already. So we have sine of 63 equals the opposite over the hypotenuse. So now we have 16 over x. So this is a good thing that we practice this one, because a lot of people want to just multiply both sides by 16 because it's the only number there. But really, you have to multiply by whatever you have on bottom. So let's find sine of 63. We got 0.8910, okay? And now we see that we have to multiply both sides by x because it's on bottom. Okay, so it's a little different than the last problem, right? And then x cancels out. So we have 16 over here, and we got x times 0.8910, okay? Well, now I want to find x, and I want to find it in the next step. So I want to divide by this, and then that will solve the problem. It'll cancel out, and we'll have x by itself on the right side. And on the left side, we'll have 16 divided by 8,910, okay? So here we go. Let's do 16 divided by 0.8910, and we get, well, I'll show you down here. X equals 17.95, okay? And so if we round up to the nearest tenth, this 5 rounds that 10 up one more time, so really it's not going to go up to anything in 17. It's going to turn into 18.0 exactly, okay? So in this case, if we round up to the nearest 10, we see x equals 18. All right. 0.0 if you want to be technical about it, okay? 18.0. So there we go. There's the other right triangle that we solved. Just make sure that when you get to this step right here, after you find the ratio, multiply by whatever you have on bottom. You don't want to be multiplying by just a number, okay? Multiply by whatever you're dividing by so you cancel that out, okay? Multiplication is the opposite of division. So make sure you multiply by whatever you have on bottom of this ratio. Well, now we got to find the inverse function, okay? So what we're going to do is go to our arc and replace that with the x and label the picture. That's our opposite. Is across in the right angle, so of course that's the hypotenuse. And so this must be our adjacent side. So now what we're going to do is look at the sides we have. We have the adjacent and the hypotenuse. So if I look at SOHCAHTOA, just to refresh my memory, which ones have the A and the H in it? Is it SO? No, it has the O and the H, okay? Is it TOA? No, it has the O and the A. We have O, we have the A and the H, okay? So we're going to have to use cosine. That's the only one that has adjacent and hypotenuse. So we're going to write cosine of what? Of this angle x over here. That's where we got our opposite from, was x, okay? And that equals the adjacent over the hypotenuse. That's 22 over 31, okay? So now what I'm going to do is go in my calculator, and I'm going to do 22 divided by 31. And then I get 0.7096, okay? If you don't bring a calculator for these problems like this, it's actually going to hold you back a little bit, okay? I might have to, I have a little calculator that I could let you borrow for those, and you could use the table, but I don't have too many extra trigonometric calculators, so please try to find your own, or borrow some from somebody for the test in another class if you can. So now what I have to do to find x degrees, I want to find how many degrees would I put in the cosine that would give me this number over here. So either you can use the table how we practice in class, and you'll look up for this number in the cosine column if you're using your book. Some people don't have their book at home. So if you have your calculator instead, you have to know how to use the cosine inverse function, which is another button on your calculator. And we're going to take the cosine inverse of 0.796. So I'm just going to hit the shift button on my calculator, and when I hit the cosine, it turns into the cosine inverse. And then I hit 0.7096, and I get enter. And I get 44.796. So I don't know if you guys can see that. Do you see that? All right, I hope you can. So here we go, all right? So we got 44.79, and it says round to the nearest degree. So what's the nearest degree if we have 44.7? Our nearest degree is 45 degrees, okay? So basically we found out that this angle over here had to be how many degrees? It has to be exactly 45 degrees. So if all you know is you have a right angle and you have two sides, you can use trigonometry to find out the angle too. And that's kind of cool, but you have to use the inverse function on your calculator just like this, okay? And this gave us, like we said, 44.79, all right? So that's the inverses. That's the way you use inverses. I want to skip over the next one so we can finish. Whoa, a little zoomed in too close, all right? So here we go. That's big enough, I hope. Well, you want to start in the triangle that has, you got, sorry. Here we go, guys. Give me a break. I'll be back on in a second. Let me just pause this.